Module 2.2. As a reminder, it is recommended to print the video script and annotate the script while watching the video for later use. Video scripts are available on Canvas. Module 2.2. What is random sampling and why is it important? If looking at the entire population is sometimes impossible, how can we learn about it? One of our primary goals in this course is to learn how to use the information in a sample to learn about a population. Don't forget, as we move through the material, that the population is the group that you would really like to learn about. If we have population data, we can examine it directly. If we are able to survey or collect information from the entire population, then we call it a census. The purpose of selecting a sample is to learn about the whole population when the whole population is unobtainable. Definition. Statistical inference is the process of using the information contained in sample data to draw conclusions about what is happening in a population. Statistical inference will provide methods to account for sampling error. Sampling error occurs when the statistic is not equal to the parameter due to looking at a sample instead of a population. We will discuss sampling error in depth later in the course. The first step to selecting a sample is to have a clearly defined population. Ideally, when selecting a sample, we would like a sample that has characteristics similar to the population's characteristics. One way to select a sample that is likely to have characteristics similar to those in the population is to select a sample randomly. Definition. A simple random sample, or SRS, occurs when every group of size n has the same chance of being chosen. It's important to notice that the definition of random sampling says nothing about the responses that people will give. A simple random sample is solely defined by how the people or other elements of interest are selected to be in the sample. In the field of statistics, random samples are very important. We need random samples to be able to make conclusions about the population from sample data. In later modules, we'll talk about sampling variability, sampling distributions, and why random samples are important. Your turn. Using the definition of simple random sample, indicate whether the following statements are true or false and tell why. For each situation, ask yourself, does everyone of interest have the same chance of being selected to be in the sample? The first one is completed for you. I decided to take a sample of students at UK. To take my sample, I stand in the middle of campus and interview students who walk by me. My sample is a simple random sample. Notice this statement is false. Not all UK students have a chance to be in my sample. For example, students who take the online course or students who were not on campus that day could not be in the sample. This is what's known as a convenience sample. Pause the video here and see if you can answer the other three. When you come back, we'll look at the answers together. I decided to take a sample of students at UK. I obtain a list of all student ID numbers and use a random number generator, which gives every group of IDs the same chance of selection to pick 100 ID numbers. I then have those students take my survey. My sample is a simple random sample. Notice this one is true. All students have the same chance to be in the sample, and all groups of 100 have the same chance of being selected together. I want to take a sample of people who live in Kentucky. I use a random number generator to pick the addresses of 50 households from my hometown. My sample is a simple random sample. Notice this one's false. People who live in Kentucky but not in the hometown do not have a chance to be in the sample. I want to know how UK students feel about euthanasia. I know that students enrolled in the College of Public Health are very diverse and reflect the diversity on campus. I randomly select 150 students from the College of Public Health. My sample is a simple random sample. Notice that this one is also false. Students who are not in the College of Public Health will not have the opportunity to be in the sample. How can we select a simple random sample? The goal is to select our sample from the population randomly. We first need to define the sampling frame. The sampling frame consists of a list of the subjects in the population. You can think of it as a menu of subjects. Previously, we saw that a simple random sample of size n consists of n individuals from the population, chosen in such a way that every set of n individuals has an equal chance to be in the sample selected. In practice, people use random numbers generated by a computer or calculator to choose samples. If you don't have technology handy, you can use a random number table. The website listed in the script gives an example of a random number table. Let's look at how to select a simple random sample. There's 2 steps. 1. Label. Give each member of the population a numeric label of the same length. 2. Generate random numbers. Your sample contains the individuals whose labels you find. For example, suppose that we have a class of 20 students and would like to take a simple random sample of 5. We will start by giving each student a label consisting of the numbers 1 through 20. Below are each of the 20 students with their label. So notice here as we look at the labels for the students, each of the labels has length 2. In other words, each label has 2 digits. So single digit numbers like 1, 2, and 3 are given the labels 0, 1, 0, 2, or 0, 3. The second step is to generate the random numbers. To take the random sample of 5, we can visit a website like the one shown here. We will need to generate one set of 5 integers where the integers are between 1 and 20. Here is some sample output. Based on the output, those students with IDs 8, 10, 11, 16, and 20 will be the 5 students in the sample. Try the website on your own to see which sample you would get. Are there other types of random samples? There are many other types of random samples. For all random samples, the goal is to obtain a sample that accurately represents the population of interest. After this video, watch the video here from the Pew Research Center. Additionally, a good website that summarizes different types of samples can be found at this link. Both of these links are listed in the script. The website summarizes both random and non-random samples. Pause the video and visit the second link to find the definitions for each of the following types of samples. After you have those definitions, come back and we'll look at an example of each one. Suppose I'm interested in the temperature of rooms in an office building. The building has 5 floors and each floor has 10 offices for a total of 50 rooms. I would like a sample of 20 offices to measure temperature. Systematic sampling would label each room in the building from 1 to 50. Then dividing the population size by the sample size would give 50 divided by 20 is equal to 2.5. Therefore, K is equal to 2. Systematic sampling says to choose a random number between 1 and K, and then since K is equal to 2, select every other room. For example, if the randomly selected number is 2, then the sample consists of the rooms 2, 4, 6, 8, etc. Cluster sampling. Cluster sampling would break the office building into 5 clusters. You can think of these clusters as groups. Each cluster would be a floor of the building. Since I need a sample of 20 rooms, cluster sampling says to randomly choose 2 of the 5 floors and use the rooms on the 2 selected floors as the sample. So notice in cluster sampling, once we break the population into groups, we randomly select whole groups. Stratified sampling would still break the office into 5 strata, or you can think of those as groups, where each strata is a floor of the building. Since I need a sample of 20 rooms, stratified sampling says to select 4 rooms from each of the 5 floors to get a sample of 20. In other words, we're going to choose some from every one of the groups. What do we do when a simple random sample is not possible? While a random sample is ideal, it's often not feasible. Notice that to take a random sample, we need to list every member of the population. A list of the entire population may not be available. Another potential problem is that it may be impossible or too difficult to contact all members of a population. Sometimes the conclusions cannot be made about the population of interest. Instead, the conclusions can only be made about a more feasible group from which you can select a sample. As a result, generalizations of the conclusions are limited to the population from which the sample was obtained. When a sample is not selected randomly, we risk collecting a sample that does not reflect the population. A biased sample will systematically miss portions of the population. If the sample does not reflect the population, then we will not be able to make good statistical inference. When this occurs, we call it sampling bias. Sampling bias occurs when non-random samples do not adequately reflect the characteristics of the population and results in poor inference. This results in an over or underestimation of the parameter. Non-random samples can have many different issues. Let's consider some non-random samples and identify some issues they may have. For example, suppose you want to estimate the average number of hours that students at UK spend studying each week. We will critique each method of sampling. Go to the William T. Young Library and ask all the students there how many hours they study each week. Notice in this scenario, sampling is based on a related variable, i.e. studying is related to being at the library. This is an issue because students at the library are probably already studying. We could tweet asking all UK students how many hours they study each week and use all the responses you get. In this scenario, we're relying on the information from volunteers. This is also known as a volunteer study. Samples comprised of volunteers tend to be biased. Volunteers tend to be people who feel strongly one way or another about a topic. Usually people without strong feelings do not volunteer. We could stand outside the student center and ask everyone going in how many hours they study each week. In this scenario, we have a convenience sample. Convenience samples contain bias because they often miss parts of the population. This concludes the Module 2.2 video.